So I mentioned an idea in class on the day we discussed vertical restraints called double marginalization. And I did not walk through the analysis in class. It's a little tricky, and I didn't want to inflict that on you unnecessarily. But someone asked me about it, and that's a natural thing to do. So I thought I would talk through this in a whiteboard format for those of you who actually want to look through the analysis. So here's what we're going to do. We want to examine how an integrated monopolist, someone who's got monopoly power at the manufacturing level and also monopoly power at the retail level, how the behavior of that monopolist compares to a situation where we have vertically separated monopolies. So we have a monopoly in manufacturing and we have a monopoly in retail, but they're owned by different people. And so rather than being operated as one giant monopoly, they're operated as two separate complementary monopolies. And so the question is how does that analysis change? And we're going to go back to the day one hypothetical that we did on monopoly power to work through that. We want to start with a situation where we have an integrated monopolist. The only difference between what I did on day one and what I'm doing here is that on day one I had a marginal cost of production of 4, had the demand curve I'm going to work with here, which is a simple linear demand curve, P equals 10 minus Q. But the marginal cost of 4 on the first day, I didn't say anything about it. Now I want to split that up. I want to have a separate marginal cost for manufacturing and a separate marginal cost for the retail level. So I'll call it the marginal cost of distribution, the marginal cost of production. I'm going to just take the 4 and split those up 2 apiece. So that the total costs in the system haven't changed. That's not a difference in this hypothetical versus a day one hypothetical. It's just a question of where those costs are set up. Okay, so what we need to do is we need to figure out marginal revenue. That's the critical tool we need to have to figure out what a monopolist is going to do. And on the first day of class, I just did a version of it where I sort of said, close your eyes, I'm going to do some calculus. There's a vastly clunkier version of it one can do that sort of maybe is a little more accessible than calculus. It has the virtue of looking like it's right, while in some sense, if you dig deep, it doesn't hold together so well. But maybe that's a better path to understanding marginal revenue. So try that here, but recognize that it's captive to the technology you're working with here, and that technology is Excel. So here's what we do: we take the demand curve, and we basically run through that different prices for the good in question. And so at a price of 10, then I pop that price in. I can compute quantity from the demand curve. That's going to be 0. I can multiply price times quantity as I would in a spreadsheet. That's going to give me 0. If the price is 9, I'm going to sell 1 unit. 9 times 1 is 9, so that would give me total revenues of 9. If the price is 8, well, I put that into the demand curve. 8 equals 10 minus Q. That means quantity equals 2. Total revenues then would be 8 times 2 is 16. And you can see how that works. And so I can sort of just plug and chug on the demand curve, put the prices in, get the quantities. That calculates the revenues. Notice the way in which total revenue rises and peaks at a price of 5 and a quantity of 5 and then works its way down. Okay, so that's the starting point. And then what I want to do is I want to calculate something that I'm going to call the revenue difference, and that's sort of an intermediate calculation on the road to creating a marginal revenue figure. And you see I've got a Excel type formula for that up here. But basically all we're going to do is we're going to calculate this 9, we're going to take the 9 adjacent to it and subtract the revenue above it. That's the revenue difference. 9 minus 0 gives 9. How do we get 7? Well, 16 minus 9 equals 7. How do we get 5? 21 minus 16 equals 5. Okay, you see how that's calculated. We do that for everything. We've calculated this revenue difference idea. And then I want to do one more version. And the revenue difference notion, you know, that's basically for each unit change. In 1 unit increments, and marginal revenue in calculus is much more refined. So the idea of marginal revenue is really as the size of the unit isn't 1 but goes to 0, and you can sort of get a version of that if you take the revenue difference and you sort of average them. So 9 plus 7 is 16 divided by 2 equals 8. 7 plus 5 is 12 divided by 2 equals 6. 5 plus 3 is 8 divided by 2 is 4. So I'm calculating a kind of marginal revenue, trying to take into account that the revenue difference was calculated using 1 unit increments, while calculus and marginal revenue really demand smaller increments, and that's what the marginal revenue does. And if you stare at that column of the spreadsheet and say, well, what's the relationship between the number I see here, let's say the 8, and my quantity, it turns out that's given by this formula. Marginal revenue equals 10 minus 2Q, and that's what we need. Remember that I can do that vastly more easily if I'm allowed to do calculus, or if you remember how to do calculus. You simply take total revenue, which is price times quantity, substitute in for price the equation we have from the demand curve, which is 10 minus Q, expand that out, and if you remember calculus, that's an easy it's easy to differentiate that and get marginal revenue, which is exactly what I've calculated there. So I've done it through this sort of hand-waving Excel spreadsheet approach. I've done it the legitimate way through the calculus approach. Both of those give me 10 minus 2Q, and then I can do the work, but I need to. Remember what a monopolist does, and now we're working on my integrated monopoly, and the integrated monopoly takes into account the marginal costs at both levels, the total cost of 4. The integrated monopoly is gonna take the demand curve, the marginal cost curve, and the marginal revenue curve. And that's going to be the marginal cost of 4, and it's at the point of intersection of those, right? The point where marginal revenue equals marginal cost. The monopolist is going to choose that as the quantity. We can then read off of that from the demand curve the monopoly price. And that's going to give rise to the result we saw on day 1, the consumer surplus, the profits, and the deadweight loss, because obviously, as you'll recall, the competitive quantity would have been here, and we've gone down to the monopoly quantity that gives rise to the deadweight losses. Which is to say that we've just repeated day 1, maybe a little faster, and we threw in the Excel spreadsheet, but we've repeated day 1. We've shown what an integrated monopoly would do. And that's what we want to use as our baseline. As we move to then separate monopolies, where we have a one monopoly at the retail level and a different monopoly at the manufacturing level, when we have those stacked monopolies, then the question is, well, what do we see happening there? And now we need to recognize that the retailer is facing the demand curve we've been using all along. So the retailer, the P equals 10 minus Q in that straight line, that represents how much consumers are willing to pay for the good. The consumers at some level don't care how the good gets to their hands, whether, how much the manufacturer charged the wholesaler, where the costs were allocated. All the consumer cares about is the price to put the good in his or her hands. And that's what the demand curve represents, the value they attach to getting the good into their hands. And so the retailer is facing that demand curve. The manufacturer is not. The manufacturer in this setup, where we've got the vertically separated monopolies, is going to be facing a demand curve that derives from the retailer's behavior. And that's what we have to calculate. Well, what does that mean here? Well, it means here that when we think about what the retailer is going to do, the retailer has to buy the good from the manufacturer. And we'll call that a wholesale price. That's how we typically talk about that. We'll call that P sub W. And that means that the price paid by the costs that the retailer faces to get the goods in his or her hands is the wholesale price plus the marginal cost. And so that's the pricing structure faced by the retailer. And so What our retailer with monopoly power is going to do is going to take the marginal revenue curve it's facing, and that continues to be the same marginal revenue curve. The retailer is facing the same demand curve from the consumers and is therefore facing the same marginal revenue curve. And what the retailer is going to do to maximize its profits is to equate its marginal cost, and the marginal cost to the retailer of getting the next unit of the good is the wholesale price plus the actual cost it experiences. So that's the PW plus 2, and it's going to equate that to marginal revenue. And if you look at that for a second, we can rearrange that a little bit, move the 2 over to the right-hand side, and then we get a relationship. And that relationship is that PW equals 8 minus 2Q. That is the relationship that emerges from the profit maximization of the retailer, given the costs that the retailer faces and given the wholesale price set by the manufacturer. And that you go and look at and you go, my God, that looks like a demand curve. We've got price on the left-hand side, we've got quantity on the right-hand side, and it's got the right shape and slope. And that's what it is. We've effectively derived a demand curve for the retailer that the wholesaler will now see, and that all comes out of the maximization decision made by the retailer given the costs that the retailer faces and given the demand curve that the retailer sees from the consumer. And so now we want to repeat the same analysis where we say, okay, so now the manufacturer is facing this demand curve, and how will the manufacturer work with that? Well, we need to do the same kind of marginal revenue calculation. So we need to come up with the marginal revenue curve being faced by the manufacturer now. We can go through the same sort of hand-waving Excel calculation where we can calculate the price and quantity and the total revenue and the incremental per unit revenue difference, this average of those, which will give rise to what I'll call marginal revenue, and then we can look for a formula that actually matches that, and that's what we get here, that marginal revenue, the marginal revenue curve faced by the manufacturer, from the derived demand from the retailer is marginal revenue equals 8 minus 4Q. We could also do that the easy way, right? We could take the total revenue of the manufacturer is going to be price times quantity. The demand curve faced by the manufacturer now is this derived demand curve, the 8 minus 2Q. Multiply that by Q. That gives us 8Q times 2 times Q squared. Again, if you remember calculus, you can easily differentiate that to get to 8 minus 4Q. That's the marginal revenue curve. And now we're ready to see what the manufacturer does. And what the manufacturer then does is the same kind of calculation, which is to equate marginal revenue and marginal cost. But now the marginal revenue curve is the 8 minus 4Q, and the marginal cost curve is that 2. Remember, when I started this process, I had, for the integrated monopolist, 4 of cost. And I split that in half and allocated 2 arbitrarily to manufacturing and 2 to retail. Now we're going to work with that 2 at the manufacturing level. And so we set 2 equal to 8 minus 4Q, and we can solve that, and now we get Q equals 1.5, and then from that we can back out what the wholesale price will be and what the retail price will be. Okay? Well, what happens there? Well, what's critical is that if we compare our original integrated monopoly situation, and that's what I had here, we got this quantity. Now how does that compare to the situation where we have the stacked monopoly? And now what we need to work with is, and add to this, is the derived demand curve. This is the demand curve faced by the manufacturer from the retailer. That's the demand curve that emerges from the maximization behavior of the retailer facing the wholesale price and its own cost. And then from that we derived the marginal revenue curve faced by the manufacturer. And given that marginal revenue curve, and given the marginal cost curve of the manufacturer, now the manufacturer is going to set a quantity, and that's what we just did algebraically, but now we're doing it graphically, at the intersection of marginal revenue for the manufacturer and marginal cost for the manufacturer, and that's right there. But as we can see, what's happened, the quantity that we sell has dropped dramatically. It's gone from the quantity that we would have seen in the integrated monopoly to now the lower quantity we see in the vertically disintegrated situation where we have the two levels of monopoly. We've lost output. And the net effect of that is that deadweight loss expands. Profits go there. And we end up with much smaller consumer surplus. And this profits turns out to be smaller than the profits that we had. So deadweight loss has gone up. Profits actually dropped compared to the integrated monopoly, and obviously consumer surplus, this small red triangle at the top, has really dropped quite a bit. So the bottom line on the stacked monopoly situation and the double marginalization idea is that two monopolies that are complements to each other are worse than one. We call this double marginalization. We have a marginal calculation made at one level, the manufacturing level, a maximization done there. We have a marginal calculation done at the retail level. And because the retailer is basing its decision making on a price that it's already infected by the exercise of monopoly power, which is to say the wholesale price already reflects the exercise of monopoly power, not the true social costs, then we actually end up with lower production. And so if the central harm of monopoly is reduced output, and it is, if you look at output here for the situation where we have one monopoly, integrated vertical monopoly, versus output in the situation where we have the two separate monopolies, we actually do worse in the situation we have separate monopolies. We would rather have them operated as an integrated monopoly, and whether they do that through merger or whether they do that through the kinds of contracts that we saw in Standard Fashion or Sylvania or Legion, that's a different discussion. But our starting point has to be, and this is what I said in class, I just didn't do an 18-minute hypothetical on it. Our starting point has to be that there are some circumstances in which we as a society would prefer to see that kind of vertical integration.